Hi there, my name is Johannes and I wanted to demonstrate my camera tracking plugin for OBS-Studio. The purpose of the plugin is to move the camera to another angle without touching it. It can be very helpful if your fingers are sticky while working on something or something like that. It makes use of IR markers and the tracking is implemented in OpenCV. It just follows a marker you hold in the camera. A marker looks like this. There are multiple different ones that you can use. And as you can see, one of my cameras is currently mounted to the monitor. This one will not move, except I'm hitting the desk with my leg or something like that. The other one, this one, will move. It is mounted on a 3D printed camera gimbal, and it will follow a marker I will show to the camera. So this is the marker, and if it detects it, like now, it tries to follow the marker and recenter. So this is just a filter for OBS video sources. So you can apply to every source you want. You just right-click the source, choose filters, and in the window that opens, in the top list, you add the filter. So then you have something that you can configure. The first one is the ID. It uses the ARUCO or ARUCO markers 4x4 dictionary, so it can distinguish about 50 markers. It defaults to ID 15, which is the one marker that is included in the Github repo, so you can print it and let the camera follow it. If you want to use another one, you just have to set the correct ID. The next option is draw marker. As you have seen, the marker is highlighted in the image. You can see it just displays ID 15 and draws a frame around the marker. This is purely for debugging purposes because it's very slow to do. The way OBS and OpenCV handle images is rather different, so the plugin has to convert between them, which is not very efficient. So turn it off if you know that your markers work. Turn it on if you want to see if the printed markers are actually detected. The next option is the frame skip option. This is purely for performance. So if you have a source that is, for example, 60 frames per second, you don't want to send a movement command to your camera every 60 milliseconds. This is way too fast. The gimbal cannot move that fast. So we can actually set up a frame skip which only tries to detect the marker every 5 frames or every 7 frames. In my demo here, I set it to 1 because if you want to see the marker drawn, you can only see that on the frames that are actually processed. So if you skip 5 frames and draw the thing for 1 frame, it just flickers on and off and you cannot really see it. I determined for 30 FPS source a frame skip around 5 is okay. The minimal trigger distance is the next option. This is just for debouncing the marker movements because webcams are rather noisy. The marker jumps around some pixels between 2 images the webcam captures, and we don't want to jitter our gimbal, so we only react if X pixels movement has actually been detected. So leave it at the default value or set it lower if your camera is not as noisy as mine. Now for the interesting bits. The gimbal is based on an Arduino. You can use an Uno or a Nano. And this is connected via a COM port. So you have to select which one you actually want to control with this filter. So with the combination of ID and COM port settings, you are actually able to use multiple swiveling cameras on different tracker markers. So for example, if you want one on the right of your desk and one on the left of your desk and have two different markers to position them. Then there's the obvious refresh button. If your Arduino doesn't show up, hit it and look at the list above. And finally, the speed with which we communicate with the Arduino. If you use the default sketch that is included in the GitHub repo, just let it on the default value. So let's jump to a quick description of the actual hardware. So this is the hardware in Onshape CAD. Onshape is a browser-based CAD tool. Everyone can use it. It's free if your things are public. So this one is public. You can use it. You can modify it. The link is in the video description. You probably have to modify it if you want to use another cam than the Microsoft Live Cam. This part here is especially done for the Microsoft Live Cam. So if you don't have a live cam, you have to redo this part. The other parts can stay. Everything that is yellow is 3D printed. This is frame around the case, the swivel arm, and the camera adapter. Everything that is blue is electronics that you have to buy. These two are Tower SG90 servos, which are very cheap, very light, and very noisy. This blue part here is an Arduino Uno. You can of course use a Nano if you want to, but I won't recommend making the base of this thing smaller than it is currently, because if you make it smaller, it will tip over. So see the link in the video description for the 3D printed parts. STL files of exactly this version are in the GitHub repo. The complete thing is available for Linux and Windows currently. You probably can do a Mac port if you want to. I think the serial port stuff has to be redone for macOS, but the other stuff like OpenCV support and something like that should work out of the box. If you have some ideas what can be made better, or just want to tell me a usage for this, feel free to comment. That's it for today. Thanks for watching.